Here's our last section about Pleasantville. So we're going to be looking at where our garbage should go. So in this section, we're going to be looking at the storage and treatment of waste, looking at dumps and sanitary landfill sites. We're going to figure out what leachates are, how soil porosity matters, prevailing winds, groundwater contamination, as well as how we can have secure landfill sites, recycling and recovery programs, and looking at the risk. So, back to Pleasantville. The City Council of Pleasantville has decided to build a new dump for the disposal of the city's garbage. There are many possible sites around the city that have been considered. The City Council has called on you as an environmental expert to help them decide if the chosen spot for the new dump is a good choice. Do some research so that you can present a report to the City Council. So, first of all, you need to know what the different options are when it comes to waste storage. So sanitary landfills are designed to hold regular garbage from cities and towns. There's an impermeable clay or plastic liner at the bottom which prevents leachate from seeping into the groundwater. Leachate is like the garbage juice, which is a really gross image in my head, but the garbage juice that can contaminate groundwater and be moved through the groundwater to other sources. So to have a sanitary landfill, you need to know that you're going to have much slower decomposition. The decomposition needs just the right combination of moisture, pH, nutrients, bacteria, gas exchange, and temperature. These landfills are designed to minimize the moisture and prevent the formation of leachate that can contaminate the groundwater. So here is an example of a 25-year-old newspaper that is still readable today, meaning that it's not decomposing very well at all. Sanitary landfills are designed to minimize moisture. They prevent the formation of leachate because it contaminates the groundwater. These landfills are anaerobic. Anaerobic means that there's no oxygen. When you're in an anaerobic area, your bacteria cannot actually decompose the material as quickly as it could if it was in an aerobic condition, so if there was oxygen present. So when you've got these landfills that are sanitary, which is good for us to have, we actually have much slower decomposition due to the conditions in which we have our bacteria. When you have a secure landfill, you are designing it to hold hazardous waste material. So this is for toxic, hazardous material that needs to be disposed of. They're very careful with these. At the bottom, they have a clay liner with a layer of gravel with a grid of drainage pipes to collect any leachate that's produced, and then a thick plastic liner, and finally sand. The sides and the top are all capped with an impermeable layer of compacted clay, plastic, and finally soil. So they're really working hard to not have this go into the soil around or into the groundwater underneath. Composting is another way that we are getting rid of our waste, and composting is probably the coolest thing in that we are just reusing our garbage to create food. So organic solid waste materials, scraps, grass clippings, anything, are put into our compost area, and then that solid waste is mixed to create compost, which is used as a biodegradable material in fertilizer. It's a wonderful way to reuse all of the food waste that we have and recycle the nutrients. So our 4 R's, as you probably know from every science class you've ever taken, are reduce, reuse, recycle, and recover. So to reduce, you want to have less waste. So we have less things to put into our landfills. Reuse, try using things again and again and again. And recycle, of course, means to use the waste, break it down, and rebuild it into other products. Recover is our fourth R. So we're using the energy from waste disposal methods to power other projects or processes. This works when we use like landfill gases such as methane. If we collect that, and then we could use that as a fuel to generate electricity that would maybe run the landfill. And so we wouldn't have to use as many, or we wouldn't have to create new fuel sources. So here's an image here where you've got your recycled pop bottles. Recycled pop bottles can be used to make clothing. They can be used to make many other things here. This is like you're reusing, so you can buy used clothing. Here we're using bits of plastic to make shoes. We're reducing our amount of products here. And then again, here's our recycling of tires is being used into certain products. Our recycling of pop bottles is being used into, pop bottles actually make great clothing. My husband and I actually had an eco-friendly clothing line made out of pop bottles and bamboo. And then over here, we have glass that's being recycled as well. So when you have your sewage treatment plant, we need to have many processes happening. So our pre-treatment is that the water goes through a grate, it's filtered and removes the big lumps, the plastics, the gravels, the sand, syringes, and all those big things are taken off and either taken to a landfill or recycled. Then we take what's left over and we have our primary sewage treatment. So this gets rid of the suspended or our floating solids. Gravity lets them settle to the bottom along with the bacteria, and they are removed and taken to the landfill. Then the water is aerated, so we add in oxygen so that the bacteria in the water can grow and eat up or decompose much of the solids that are still floating in the water. So those biosolids, the sludge that's connected at the bottom of the tank, they can be used for composting or for fertilizer. So this is recycling our nutrients, getting our nitrogen and our phosphorus all back into the soil. Biodegradable materials can be broken down by the bacteria or fungi or other organisms into the carbon dioxide and water. Lastly, we remove the phosphates, the nitrates, and the algae. This is followed by a chlorine treatment to kill the bacteria and other microorganisms. Dechlorination must follow so that the natural ecosystem is not contaminated with chlorine. And then we have alternatives to chlorine treatment. So UV light can be used to kill the microorganisms, but that uses more electricity, of course. And ozone treatment can be used, but that's more expensive. So then our final treated water is called effluent, and it can be safely used and released. So here's some images to help you with how that would work. So first of all, it's screened, then it's allowed to settle out. Then we stick in the bacteria, which goes through and eats all of the stuff, and it's settled out again. And then it can go and be used to go through this nutrient stripping, and it is usable. The methane, of course, comes out here, and the sludge is used for composting. Again, just another image to help you look at that, and kind of a lovely diagram here on how these different systems work to get our sewer waste back to where we can actually use it. All right, on to the questions.